Tidal energy has the advantage of being a predicted renewable energy. At this moment we have a worldwide demand for renewable energies, and tidal energy can be predicted, especially on the Atlantic area where we have relevant tidal ranges, and in several coastal areas we have associated important currents. Therefore, on the Atlantic area it is important to try to develop better extraction for tidal energy in the future.
The TIDES project is an international cooperation between different partners to look at ways of understanding the extraction of energy from the tides, and the project looks to exploit that resource at a particular site which is in Portugal, in the Rio Formosa. We're bringing together partners from 5 countries, that is the UK, Portugal, France, Spain and Ireland, and we have different skills that we're bringing to the consortium. We're including physicists, oceanographers, marine biologists, engineers, modelling people and marine engineering as well. We're including universities and people from within the local authority and the councils. So really we have a wide range of skills from biology to engineering in order to be able to understand what's going on in this particular environment. So the state of the art is that there are a number of tidal devices which are now at commercial scale, but the development is really hindered by a lack of environmental information. The devices that have been installed so far have commercial restrictions on the data from those projects, so although there has been no environmental impact so far, that information is being kept by the project developers. Our aim is to widely disseminate all of the information that we gain in an open source way so that various stakeholder groups can understand the potential impacts or the lack of impacts from tidal energy extraction in our estuaries. The European resource is quite significant in tidal energy, maybe 16 gigawatts of power, which is a significant contribution to the European energy mix. It promotes security of supply and a diversity of supply as well, and sits alongside and complements solar and wind and the other renewable energy options.
Tidal energy is generated in a way that we can compare with wind turbines. In this case we have a fluid, water, passing through blades, and those blades by rotation will generate tidal energy. So it's not very much different from what we know already on wind turbines. The main difference is that the density of the water is higher, and therefore for the same blade dimension it is possible to generate a higher level of energy and power. So the possible output of tidal generators can be even bigger than wind turbines for similar blade conditions.
So the objectives of the project, it's a joint project, and we're looking at what happens when you deploy a tidal turbine into a coastal estuary. So the first thing we're going to do is we're going to understand how much energy we can extract from this particular channel in Portugal. The second thing we're going to do is to deploy a tidal turbine into that channel, and then we're going to spend a long time gathering some very detailed measurements of both the performance of that device from an engineering sense and also its interaction with its environment from a biological, hydromorphological basis as well. So we're looking at both the engineering and the environmental interactions of this device in this channel. We're then going to use that information to think forward, to thinking about arrays of devices, and to look at what we can learn about the specifics of that particular location, what are the specific impacts, and also we're going to try and understand what are the generic impacts on channels like this one from this type of tidal energy extraction. Finally, we're going to wrap all of that up with a techno-economic evaluation of the benefits to the economy and to the environment for doing this type of project. The prototype device is one that's been under development for a number of years now and is quite mature. It's a floating device. It floats just below the surface, and it's a tidal turbine, so it looks like an underwater windmill generating energy from the flow of the current. It's 1.5 meters in diameter and 1 kilowatt in power output. The idea is that at full scale these devices would be perhaps a little larger than this and would be installed in multiple units. In terms of results that relate to the site, so we're going to be looking quite carefully at the geophysical, hydrodynamic and sediment characterisation of that particular channel, and that will give us valuable data in order to inform future environmental impact assessments of devices deployed in similar channels around the European coastline. This will make future projects more attractive to governments and to investors. It takes away the consenting risk that a project may not be able to happen because there is no consent to deploy. And that's driven by the requirements of the Habitats Directive.
This project will be structured on 7 work packages. One of the work package will be devoted to the management of the project, while another one will be mainly dealing with dissemination not only to the scientific public but also to stakeholders and to the industry. The core of the project will deal with the device implementation at the prototype site, the test site in Rio Formosa, the lagoon, and its test for 2 months. It will also deal with the modeling of the coastal area, including potential environmental impacts and how the environment affects the device. A database will be created using all the knowledge around this coastal area and also all the knowledge acquired during the project. And at the end of the project, a cost-benefit analysis will be made for this type of devices and power extraction.
I think, yes, that this project will have a significant positive effect on the Atlantic region. Firstly, the partners will be much more working together and effective in being able to promote and have a real depth of expertise in this particular emerging and growing industry sector. Our associate partners, particularly at the local government level, will be able to talk to their communities, will be able to explain what this type of technology is, how it may affect both the positive and negative effects of tidal energy on local communities. We believe the effects are mostly positive, but there will obviously be people concerned about a new technology, so that's important. And also what we're doing can inform policy at both regional and European level, where we can inform future policy on tidal energy deployments and how they should interact with the environment which they're placed into.